Okay, today we're talking about lesson 4.22, module 4, lesson 22. You'll notice we skipped module 4, lesson 21. Did you guys notice that when we were writing down our lessons? Yeah, and the reason for that is because 21 is too easy, or it's combined. I'm going to combine it with lesson 4.22. Okay, does that make sense? So your learning goal today is to be able to compare the size of the product to the size of the factors. Now, if you read the learning goal on the board, it says compare the size of the factors to the size of the product. I switched those two words around. Does it matter? No, it means the same thing. Okay, so we're going to take a look at the factors and see how they affect how the product will come out. Okay? We're going to practice multiplying fractions by whole numbers. So what's 10 times 1/2? Okay, what's 1/2 times 10? 5. What property says that these two problems are the same? The commutative property of multiplication. Did you basically do a division problem in your head to figure that out? What division problem did you basically do? 10 divided by 2, right? Because is that equivalent to 10 times 1/2? Yeah. Okay, let's use that knowledge to do this one. 1/3 times 12 is the same as what number divided by what number? 12 divided by 3, which is 4. Very good. So then what's 12 times 1/3? 4. Because it's also 12 over 3, isn't it? What division problem is 8 times 1/4? 8 divided by 4. And written as a fraction, it would be 8 over 4, which is 2. So if we know that 1/4 of 8 is 2, how much is 8 times 4/4? 8, yeah. And then how much is 8 times 5/4? 10, because we know that 8 times 1/4 is 2, so 5 of those fourths would be 2 times 5, which is 10. If we're going to skip count by tens, it goes 10, 20, 30, 40. Let's do that together. Ready? Go. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. How many times did we have to skip count before we got to 100?
10.
10. So therefore, 10 times what?
10.
10 equals 100. Okay? So 10 copies of 10, we have to skip count by 10 times to get to 100. Now let's do the same thing, except we're going to skip count by 20s until we get to 100. Ready? Go. 20, 40, 60, 80, 100. This time, how many times did we have to skip count? 5. So therefore, 20 times 5 equals 100. Okay. Now let's skip count by 4s until we get to 100. Are you ready? Let's go. 4, 8, 12, 16, 20, 24, 20. 60, 64,
68, 72, 76, 80, 84, 86.
84 and then? 88, thank you. 92, 96, 100. Okay, if you saw me counting my fingers, that was 25 times you had to say a number. So therefore, 4 times what? 25 equals 100. Very good. Now let's skip count by 25s until we get to 100. Ready? Go. 25, 50, 75, 100. How many times did we have to say numbers that time?
4.
So therefore, 25 times 4 equals 100. Very good. If I'm going to find 4/4 of this 12 inches, how long will my ribbon be? 12 inches, won't it? Okay, so go ahead and write 4/4 times 12 inches equals 12 inches. Now, what if I don't want 4/4? What if I only want 3/4 of this ribbon? Do I want my entire ribbon? Do I want more than this ribbon? Or do I want less than the ribbon? Because I only want 3/4. I don't want the whole thing. I just want 3/4. So I would fold it into fourths and then cut off one of the fourths, right? And it would get shorter. In fact, why don't I do that? So will 3/4 of 12 inches be greater than 12 inches or less than 12 inches? Less. So is the product going to be less than the factor of 12 inches or more than the factor of 12 inches? Less. How much less? Well, let's find out. Let's do 3/4 times 12. Is there anything we can cancel out? Yeah. We can say the 4 is 1 and this is 3. So the answer is 9 inches. Were we correct in that our product was less than our factor of 12 inches? Yeah. What if I want 5/4 of that ribbon? Is it going to be more or less than 12 inches? More, because I want more than 1 whole, more than 4/4. So let's find out if we're right. 5/4 times 12, again, we can cancel this out, right? It's going to be how many inches? 15 inches. Were we correct in that our product was more than our original 12 inches? Yeah. So I'm going to show you what these three problems, 4/4 times 12 inches, 3/4 times 12 inches, 5/4 times 12 inches, what do they all have in common? 12 inches. We're all finding something, some fraction of 12 inches. The fraction is called the scaling factor. So 4/4 was the scaling factor in that problem, 3/4 was the scaling factor in that problem, and 5/4 was the scaling factor in that problem. I want you to write this down. A scaling factor is the factor that is affecting the size. We know that fraction, 4/4, 3/4, or 5/4, is the one affecting the size of the product, right? Because the other ones are all the same, 12 inches. Do you see what I mean? Scaling means making something bigger or smaller. You know how when you draw a map to scale, you're drawing, like on your hiking trail, how you're drawing it to scale? Are you really having 60 kilometers or 6 kilometers? No, you're shrinking everything down, but you're keeping the relationship of the distances the same. So that's to scale. Does that make sense? So scaling means you're making something bigger or smaller. So the scaling factor is the factor that's affecting the size. Let's take a look at these scaling factors. How did the scaling factor of 4/4 affect the size of the 12 inches? Did it change the size of it?
No.
It stayed the same because 4/4 is equal to 1. How did the scaling factor of 3/4 affect the length of 12 inches? It made it smaller because 3/4 is less than 1. How did the scaling factor of 5/4 affect the size, the length of the string? Made it bigger because 5/4 is greater than 1. So what relationships are we seeing about the scaling factors? Talk to your table group. Now, the first direction says to circle the scaling factors. Let's take a look at these three problems. Is the scaling factor always the first factor? No. In fact, in this case, what do these three problems have in common? 1/2. So is 1/2 the one that's changing, or is 1/2 the one that's being changed? 1/2 is the factor that's being changed. The scaling factors here are, let's circle them, 5/5, 9/5, and 3/5. Okay. Now, let's go ahead and do the math so that we can answer the second part that says how will they affect the products. So 1/2 times 5/5 we know is going to be what? 1/2, because 1/5 or 5/5 is just another version of what number? 1. And I'll prove it to you. 1/2 times 5/5. Do we see any factors in the top numerator and denominator that we can cancel out? Anushka? Oh, 5 and 5 are both divisible by what number? 5. So is that the same as 1/2 times 1/1? Which is equal to? 1/2. So how did this scaling factor of 5/5 affect the product? It kept it the same as the original factor, yes? Okay. Now let's take a look. Here we have 1/2 times 9/5. Let's go ahead and do that math. Are there any factors we can simplify? No. So this is equal to 9/10. How does 9/10 compare to 1/2? It's bigger. 9/10 is almost 1, and half is only half. So it got bigger, didn't it? How come? How is the scaling factor?
It's greater than 1.
It's greater than 1. It's greater than 5/5. 9/5 is more than 5/5. Would you agree? So therefore 9/5 is greater than 1, and it made the product get bigger than that other factor. Because we have more than 1/2, don't we? Okay. Now let's take a look at this one. 1/2 times 3/5. Again, there are no factors we can cancel out, so this equals to 3/10. Is 3/10 more or less than 1/2? Less. So how does this scaling factor make it so that it's going to be less than the original number? Aditi? Yeah, 3/5 is less than 1. So can our answer, if we only have 3/5 of 1/2, Will our answer be greater, equal to, or less than 1/2?
Less than.
Less than. So at least